Tonight's is the first movie in a series on types of reactions. So this first slide is designed to give you an overview of what you can expect over the next roughly week or so. Classification is helpful in a lot of areas of our lives, and in chemical reactions what it allows us to do is it can predict a variety of things. First of all, it can help us predict if a chemical reaction is even going to happen. It'll help us with identifying the conditions needed for the reaction, any precautions we need to take around that type of reaction, and lastly, what the products will be. Moving on now. The first type of reaction we're going to look at today is synthesis. The others we'll deal with on other days. Synthesis reactions, as you may recall from grade 10, always produce one product from two or more reactants. Moving on to the next slide now. The first version is two elements react to make a binary product. Binary simply means only two elements. If we first look at a univalent metal, so multivalent means more than one possible charge, univalent means there's only one charge possible. A univalent metal reacts with a nonmetal and you get an ionic product. An example of this would be taking 4 sodium atoms and 1 oxygen molecule and making sodium oxide. In contrast, if you have a multivalent metal reacting with a nonmetal, you still get an ionic product, but let's have a look. If you take copper with oxygen, you can get copper 1 oxide, which is brown. If you do it again, under different conditions, you will get copper 2 oxide, which is red. In these cases, if you control the reaction conditions, like temperature or oxygen supply, you can determine which product you're going to get. For this particular reaction, once you have a little more experience, you'll be able to say the higher temperature allows us to have more of the copper 2 oxide. Lower temperature produces the copper 1 oxide. And this is part of the direction we're going with this, is to anticipate possible products and then what kind of conditions we can use to get one versus another. Moving on now. What happens if we have two nonmetals? Well, we get a molecular product. For example, carbon plus chlorine making carbon tetrachloride. Notice the states are all driven by what the substances actually are, not where the reactants came from. Moving on to the next slide now. The second version of synthesis is when you have an element and a compound reacting to make a new compound. This is pretty common in our atmospheric chemistry. An example is sulfur dioxide will react with oxygen in the air to make sulfur trioxide. You might remember a little bit of this from our acid-base chemistry in grade 10. Moving on now. The last one is two compounds react to make a new product. Some of these again are familiar from our acid-base chemistry. So here is liquid water with sulfur trioxide like we made in the last example to make liquid sulfuric acid. Similarly, that sodium oxide that we made earlier can react with water to make sodium hydroxide. So you're going to notice that we often get a polyatomic ion. Expect that the reaction will make a polyatomic ion. Another example, HCl gas and ammonia gas will react to make ammonium chloride as a solid product because it's both of the reactants are molecular compounds. However, when they react, you get a polyatomic ion, and so you get a solid being produced. That's our start to synthesis reactions, and we'll be doing some more practice in terms of recognizing synthesis reactions, writing the products for synthesis reactions, what kind of reactants we need for that, and of course, balancing. Thanks for watching.